2-3, solving absolute value equations and inequalities. Remember, absolute value is the distance between a number and 0 on a number line. So when you're looking at these, you have to go ahead and form two different equations or inequalities when you're working with this. If we look at example 1, we're solving the absolute value of 3x minus 2 is equal to 8. So your first idea here is to get rid of anything on the same side as with the absolute value bars, because the only thing you want left on that side is the absolute value of whatever. So in this case, we don't have anything on that same side, so we can form two separate equations, one with a negative answer, one with a positive answer. So this is going to give us 3x minus 2 is equal to negative 8, as well as 3x minus 2 is equal to positive 8. From here, you want to work with one of these separately. So you're working with two separate equations now to get two separate answers. So with the 2, you're going to add it over to the other side to get 3x is equal to negative 6. From here, divide each side by that 3, and you get that x is equal to negative 2 for one of the solutions. Look at the other equation now. Do the same thing. Add the 2 to both sides. You get that 3x is equal to 10, and then you're going to divide by 3 on both sides to get that x is equal to 10 over 3, or 3 1/3. So both of these are your answers. If we look at our next example, example B, we're now dealing with an inequality. Remember, when you divided or multiplied each side of that inequality by a negative, you switched the sign. So when you rewrite this to be two separate inequalities, you're going to have the one that they give you without the absolute value bars, as well as the one that they give you with the opposite sign and a negative answer. Okay, so for B, they give us the absolute value of 3 minus 2t is less than 5. You see that there's nothing on the same side as the absolute value bars, so we're going to rewrite as two inequalities, one with a negative 5, one with a positive 5. Because the positive 5 is the same thing as our original inequality, we're going to leave that sign, that inequality sign, the way that it's open to. When we change that 5 to be a negative 5, we're going to switch the sign to be open to the left, and then work from there. So the 3 is going to be what you're moving over first. If I'm working with the 3 minus 2t is greater than negative 5, I'm going to subtract the 3 from each side to get negative 2t is greater than negative 8. Now from here, you have to divide each side by that negative 2. Remember, when you're dividing by a negative, you switch the sign. So the negative 2's cancel out. You're left with t, switch the sign, is less than negative 8 divided by negative 2 is a positive 4. If you look at the second one, we have 3 minus 2t is less than 5. The 3 is going to be moved over, so we're going to subtract the 3 from each side to get negative 2t is less than 2. And then we're going to divide each side by negative 2, flip the sign. We get that t is greater than negative 1. Now from here, you have to take this a little bit further. Look at the way that your inequalities are. Rewrite them to where your inequality that includes the smaller number comes first. This would be the t is greater than negative 1. So t is greater than negative 1, and then you also have t is less than 4. So what type of inequality, compound inequality, is this? Those signs go in towards each other. So if we were to graph it, it would become an and statement. So your solution here would be negative 1 is less than t, which is less than 4. It has to be that compound inequality. Like I said, with these, once you get your answers with the inequalities, you got to take it a little bit further and give the compound inequality, whether it be an and or an or statement. If we look at the next example that we have, for 2a, we have the absolute value of 2z minus 1 plus 3 is greater than or equal to 8. So this time we have that plus 3 on the same side as that inequality, and we want to move that over first before we change our answer and to be a negative as well. So that 3 moves over. We're going to subtract 3 from each side and get that the absolute value of 2z minus 1 is greater than or equal to 5. From here, we're going to separate into two inequalities. So we're going to have 2z minus 1 is less than or equal to negative 5, as well as 2z minus 1 is greater than or equal to 5. Start moving things over to get that z by itself now. If we're working with the one on the left, I'm going to add that 1 to both sides to get 2z is less than or equal to negative 4. And then I'm going to divide by 2 on both sides to get that z is less than or equal to negative 2. If I look at the one on the right, the 2z minus 1 is greater than or equal to 5. Add the 1 to both sides. We're going to have 2z is greater than or equal to 6. And then divide each side by 2 to get z is greater than or equal to 3. Now look at your inequalities. These inequalities, the one that includes the lesser of the two numbers is on the left, so we're good. Look at the way those signs face. They're facing outward, which means this is an or statement. So this is going to be z is less than or equal to negative 2, or z is greater than or equal to 3. And remember, guys, if you're asked to graph these, which in this case you are, your graph is just going to be the same way that we've been doing this. So we're going to have closed circle on 2, the line's going to go to the left, closed circle on 3, the line's going to go to the right. For B, a little bit harder now. So we have 4 plus 2 times the absolute value of 3x minus 5 all over 2 is greater than 5. So again, undo that addition or subtraction before you undo multiplication or division. So the 4 is what we're going to be moving over first. Remember, you cannot combine that 4 and that 2 because that 2 is being multiplied by whatever the absolute value of something is. So again, you have to undo that addition or subtraction first before you undo the multiplication or division. So we're going to subtract 4 from each side to get 2 times 3x minus 5 over 2 is greater than 1. So from here, we're going to divide each side by 2, and we're going to be left with the absolute value of 3x minus 5 all over 2 is greater than 1/2. So now, turn this into two separate inequalities. So we're going to have 3x minus 5 over 2 is less than negative 1/2, as well as 3x minus 5 over 2 is greater than the positive 1/2. So work with the inequality on the left. We're going to get rid of that 2 on the left side by multiplying each side by 2. So these are going to cancel out. We're going to be left with 3x minus 5 is less than the 2's become 1's. So this is negative 1. And then from there, we're going to add the 5 to both sides to get 3x is less than 4. And then we're going to divide each side by 3 to get x is less than 1 1/3 or 4/3. Now go back to the other one on the right side. You have 3x minus 5 over 2 is greater than 2. So again, we're going to multiply each side by 2. Those 2's are going to cancel. Becomes 1's. So that's going to be 3x minus 5 is greater than positive 1. So move the 5 over, add it to both sides. So 3x is greater than 6. And then divide each side by the 3. To get that x is greater than 2. So now look at your two inequalities. They point opposite ways. Your one with the lesser is on the left, so you're good. So this is an or statement. So this is going to be x is less than 1 1/3, or x is greater than 2. And if you were to graph this on your number line, 1, 2, there we go. You're going to have an open circle on that 1 1/3, and your line's going to go to the left, and you're going to have an open circle on that 2, and your line will go to the right. If we look at our next example, we are solving these, same exact thing that we did in the beginning. So there's nothing on the same side as that absolute value bar, so rewrite as two equations. So we have x minus 3 is equal to negative 2, as well as x minus 3 is equal to 2. So keep working from here. From the left, you're going to add that 3 to both sides. So x is equal to 1. Same thing with the right. You're going to add that 3 to both sides and get x is equal to 5. So your x is equal to 1 and x is equal to 5 are your solutions. If we look at B, we have the absolute value of y plus 2 is less than or equal to 3. So again, form two inequalities. You have nothing on the same side as the absolute value, so you go straight into forming two inequalities. So y plus 2 is greater than or equal to negative 3, as well as y plus 2 is less than or equal to 3. For here, we're going to subtract 2 on both sides to get y is greater than or equal to negative 5. And then same thing with the other one, subtract 2 on both sides to get y is less than or equal to 1. Look at your inequality signs. The lesser of the two numbers are with the inequalities is on the left, so the inequality signs point in towards each other. So there's going to be an and statement. Rewrite it so you have your smaller number, your variable, your larger number, and make sure those signs stay open to the term it's supposed to. With the y is greater than or equal to negative 5, it's open to the y, so it's going to stay open to y between the negative 5 and the y. For the y is less than or equal to 1, it's open to the 1, so between the y and the 1, it stays open to the 1. And for C, we have the absolute value of 5 minus 2t is greater than 3. So again, there's nothing on the same side as that absolute value bar, so rewrite it as two inequalities. So 5 minus 2t is less than negative 3, as well as 5 minus 2t is greater than 3. Start moving over. That 5 moves over first by subtracting it from each side, so negative 2t is less than negative 8. And then divide by negative 2, switch the sign. We get t is greater than positive 4. Go back to the other one. Again, subtract that 5 from both sides. You get negative 2t is greater than negative 2. Then divide each side by negative 2, switch the sign. T is less than positive 1. So again, you have t is greater than 4 and t is less than 1. You want to rearrange these to where the inequality that includes a smaller number comes first. So t is less than 1, as well as t is greater than 4. Look at those signs. They point opposite directions, so this is an or statement. So your answer for this one would be t is less than 1 or t is greater than 4.